Okay, we've talked about power use, and we know that the formula for power is P is equal to VI. That's the simplest. Oh, writing off the top of the screen, whatnot. That's the simplest formula for power, and we know you can derive two other formulas from here, which are easy enough. And we know that V is equal to IR. So we can put IR in here for V. We can know that power is equal to I squared R. And then we could solve for V here. I mean, we could, for I, we could put the R here. We could put V over R, and we would know that P is equal to V squared over R. So we know all four of these formulas, all right? Now, my first question to you would be this. This little puzzle, we're going to be working with actual schematics and circuits, all right? Using the available formulas, knowing that this is a 60-watt bulb, 60 watts, okay? So if this bulb right here is using 60 watts of power, what is the resistance in ohms of this bulb? What is the resistance of this bulb? I'm going to give you a chance to use these formulas and solve it. All right? Here's what I would do. I'd say, okay, first thing, I would want to know what the current was in this circuit. So using P is equal to VI, I would say 60 watts is equal to 120 volts times what current? So now I know the current here is 0.5 amps. Now that I know this 60-watt bulb uses 0.5 amps in a 120 volt circuit, now I can easily calculate the resistance of the bulb using V is equal to IR. 120 volts is equal to 0.5 amps times a certain resistance. 120 divided by 0.5, that is a 240 ohm resistor. Does that make sense to you? All right. If you missed that one, let's try another one. Here's your shot at redemption. This is the exact same problem. We're just going to be doing it in a different way. We've got 120 volts. It is now going to be running. This bulb right here is going to be a 90-watt light bulb, which those are very popular. They're very bright. And then also on another parallel circuit to it, we'll be using a light bulb that's very bright. It'll be 120 watts. All right? So my question to you would be, what is the resistance in ohms of each of these bulbs? And then my last question for you would be, is what is the current in the wire here? How many amps are here, here, and here? All right, these are questions you'll need to be able to answer. All right? So let me ask these questions in order. All right? The first thing I would ask you is to calculate, and I'm going to ask you these in an order that will help you get them right, okay? The first thing I would ask you is to discover the current right here. If there's a 90-watt bulb on a 120 volt circuit. Now remember, this circuit's parallel, so this wire right here is connecting to both sides. There's 120 volts across here. All right, what is the amperage here? Go. All right, hope you got it right. Let's see if you did. You would simply say P is equal to VI. We have a 90-watt bulb. And there's 120 volts across there. So let's solve and see what that I is. We end up with 90 over 120. So 9 out of 12 is 3 out of 4. So 0.75 amps. Does everybody agree with that? Great. All right. Now that you know the current draw across here, now that you know the current draw, I want you to tell me what is the resistance of this 90 watt bulb pulling 0.75 amps on 120 volts. Go. All right. Next thing, to find the ohms, we'll simply say V equals IR, just like in the last sample problem. 120 volts is equal to 0.75 amps. And what is the resistance? We end up with 120 divided by 0.75. Do that with my calculator real quick. 160 ohms. All right, let's try this one up here. Up here at the top, right? First thing I would ask you, what is the amperage? There's 120 volts here with a 120 watt bulb. Go. All right, here's how we'll solve that. We'll say P is equal to VI. Okay, the power being used is a 120 watt bulb. There's 120 volts available, so it's 1 amp. That's simple enough, right? Now my next question is, what is the resistance of a 120 watt bulb with 120 volts? No problem. V equals IR. 120 volts at 1 amp means you have 120 ohms of resistance. So this is 120 ohms. That makes everything nice and neat, doesn't it? So now we've discovered the resistance of bulbs just knowing their wattages. We've done that 3 times now. And very, very simply, last question, what is the current moving through the wire at this point on the parallel circuit? Yep, 1.75 amps, because this current's going through there and that current's going through there. Hope you got it.